Hey guys, this is Wojtek, and today we're going to take a look at how to leverage spline components. Specifically, we're going to take a look at how to create a new actor that leverages a spline component, as well as we're going to take a look at some properties that are being exposed by that spline component. We're also going to override the onConstruction method signature in order to allow us to render our spline components within our world level. We're also going to take a brief look at how to add alternating materials, include some starting and ending caps for our spline, as well as how to drop it into our level and have our character interact with it. So, let's get started. So, in order to use our spline actor, first we need to go ahead and create a new class that inherits from the base class of actor. So I'm just going to go ahead and create a new folder under our props folder here. I'm just going to organize it by spline, and we're just going to generate a new class before we start working on our blueprint. So, just using the base actor class, I'm going to go ahead and drop this new spline actor within our props folder. Let's do this, and let's call him our spline actor. There we go. With our spline actor now available, let's go ahead and start decorating our header with some of the various properties we're going to need for this thing to actually work. So the first one we're actually going to go ahead and generate is our spline component. So we're just going to make a new U property. We are going to, actually, you know what, we're just going to make this guy visible anywhere and the category of spline. So our spline component, as you can see, is currently not referenced, and my handy dandy Resharper add-on is letting me know that, hey, I need to include this additional header file. So once we bring it in, our compilation issue should go away, and then we can go ahead and bring in our property. So this is going to be the primary component that actually handles the distribution and presentation of all the various meshes we attach to it. But in order to actually be able to do that, we also need to define a couple of meshes. And actually, in this case, we're just going to look at the base mesh and see how that plays with our spline. So we're going to make this a edit anywhere, blueprint read and write property in case we want to be able to override it at runtime, and we'll also give it a category of spline. So this is going to be our static mesh. So it's going to be use static mesh. I'll just say mesh for now. And yeah, you know what? Let's just go with this for the time being. We'll add more stuff as this little project develops. So going back to our CVP class, let's go ahead and initialize our spline component. So we're going to say create default subobject. It's a spline component type, and let's give it a name. Cool. If our spline component was initialized correctly, then we can go ahead and set it to be our root component. And this simply eliminates warnings within UE4 editor about missing root components. So always make sure to eliminates. There we go. So always make sure to have a root component defined, as it does assist the engine in just recognizing how your object hierarchy is is set up. So cool. We have our spline component. And now what? Well, one thing you will notice, and we actually save this, compile it, and I'll show you in the editor real quick. Okay, so with our project recompiled, we can now go ahead and actually leverage the spline actor as part of our blueprint. So under our prop spline directory, we're just going to go ahead and add a new blueprint class. We are going to leverage the spline actor as our parent class. And we shall call this spline test. So there's our new blueprint. It's leveraging our spline component that we added, and it has our mesh exposed. Now, if you look at a spline component, there's a bunch of different properties we can sort of manage. There's some physics, rendering, collision definitions, very, very sort of standard spline stuff. But we're not going to be managing our spline component through the blueprint too much. We're going to use our C++ code for that. One thing to note is we are going to be also leveraging the C++ version of the construction script. Now this guy here is accessible through the onConstruction API call. And this is where we're going to handle a lot of the logic that is responsible for rendering and presenting things along our spline. For folks who are not familiar with splines, splines give us the ability to basically render this line with many, many points. And all I'm doing here is I'm just holding down Alt and dragging our transformation gizmo from the last point in the line in order to add sort of more things along this path. And then once you have these points defined, you can transform them. We have our tangents here, so you can kind of adjust how things end up rotating. We end up, sorry, I was trying to rotate the tangent. We can reshape this path to be whatever sort of structure we want. And what's important to note is all of these points is what allows us to render and move things along said spline. So let me just go ahead and yank all of this junk out, and let's go back into the code to see what that looks like. So I mentioned the construction script. We want to call the onConstruction function, and we're going to override this guy. Now, I am using Resharper as a plugin, which gives me all of these little handy features to have access to the Unreal API. No worries, I will be providing all the links to the documentation, so you can do this all by hand. There is our onConstruction override, and let's just go ahead and look at its implementation. So, called when an instance of this class is placed in an editor or spawned. It passes the transform, and the transform represents the sort of the structure of this definition within our world space. So when we drop it in, the transform gets passed in, and then you can make certain decisions based on that. So cool. We have our own construction. We're just going to go ahead and generate the implementation for that. So what are we going to do in the implementation? Well, we need to move along all the points within our spline and then render things along said points. So we're going to do that by simply iterating over our point count. So we're going to define a spline count variable. We're going to say less than spline component and get number of spline points. So this is going to be the total count of all the points we have available in our spline, and we're going to iterate over them one by one and do stuff. So we're just going to ensure that we're not hitting any index out of bound problems. And let's go ahead and increase the count on this guy. Oops. So there's our loop. Now within this loop, what we want to do is actually generate individual spline mesh components and attach them along set points. So this is going to allow us to have different parts of our fence or our piping or whatever sort of object we want to generate using the spline. So for that, we're going to use a spline mesh component, and and I don't believe I have the inclusion for that, so let's throw that in a second. It's going to be a spline mesh, and we are going to say new object, new spline mesh component, and okay, there's our inclusion for the header, so make sure you have this guy available to you. And we're going to pass our current object as well as the actual class definition for that. Cool. So this gives us our spline mesh component. Let's make sure we're using good variable nomenclature. So now what? Well, let's go ahead and actually grab our the mesh we're going to be leveraging. So remember, we added this guy right here, the static mesh. So what we're going to do is we're simply going to say spline component set mesh. Oh. Oops, sorry. Spline mesh component set static mesh, and we're going to pass in our mesh. In addition to that, we also want to set the we also want to set the mobility of set component. And this is not working because of a typo here. Set mobility. Here we go. So E component mobility, and we want to make sure it's movable. So as you can see, there's a couple of different enums you can pass in here. Since we want this thing to allow for mobility, we're going to highlight it as such. But if you have a static thing that doesn't require any sort of additional fancy rendering, don't worry about it, set it to static. So we have our mobility. In addition to that, we also want to say the spline mesh component create method, creation method equals use construction script. So we're deferring the construction to the blueprint's construction script. Now, what else? We also need to register this component with the world. So we're going to pass in our world. And what else? We also need to attach it to our component. So attach to component. And this is going to go into our spline component. And our transform rules are going to be relative. So again, attach it relative to the spline component along said point within that spline. I'm sure this is making all kinds of sense. Okay, now what else do we need to do? Well, we need to ensure that the starting and the ending point of our mesh is sort of within the bounds of the points that we're generating along. So what are we going to do there? Well, we're going to have to generate a couple starting and ending points of where this thing's going to go. So let's go ahead and define a couple of vectors. And we're going to have a starting point, start point, and this is going to be spline component, get location at spline point. So this is our spline count, and eSpline, this is going to be the eSpline coordinate space. There we go. and this is going to be our local space. So there's our starting point. Now we need a starting tangent. And tangents, just to go back to this, are these little guys here. So these are the guys that control sort of the curvature and the way those points end up sort of flexing along the length of that spline. I'm sure you can do a lot of interesting math reading about tangents and how they all work, but that's essentially the dumb version of how I interpret them. So we need the same thing. Oh, sorry, not location, get tangent at spline point, spline count, and we're also going to type in the local space for our coordinate. Cool. Now we're going to need the same thing for our ending points. And I'm making these just const because we are not going to be adjusting those values as we iterate over this loop. So ensure you correctly apply type safety to all of the things you're going to be working with. So we're going to get the ending point, which is going to be spline count plus 1. Seems pretty simple. And this is our spline coordinate space, local, and tangent. Spline component, get tangent, that's spline point, plus 1, and our local space. Cool. So actually, let's go ahead and assign these values now. So spline component or spline mesh component, set start and end. And as you can see, it takes in all of our values. So start point, start tangent, end point, and tangent. And let's do an explicit true on the update mesh, even though it's implied as a default. But I always like to fill in all of the API signatures of, especially if they have sort of meaning to me as the developer. Additionally, you can do things like spline mesh component, set collision enabled. We can set the profile name, and if we want to be able to interrogate any of the collision events, similar to any other sort of any other actor, you can just go ahead and define, are we doing physics, are we doing querying physics, etc., etc. So you have a number of different properties you can affect on this particular spline component. So once this is all set up, we should now have things generating along our mesh. So let me go ahead and recompile, and let's see what this looks like. Oh, actually, you know what? Before we do that, because our mesh can be null, we probably don't even want to address any of this logic if our mesh is non-existent. So if our mesh is not a thing, then we just return. Okay, let me recompile and let's take a look. So with everything recompiled, let's go back to the editor and see what we can do now with our spline component. So there's our guy. Now let's go ahead and pick some sort of static mesh that we can play with. You know what? Why don't we just go with a classic old cube. So as you can see, we've gone ahead and added in our static mesh, and now it's rendering along our spline. Now, because it's a 2-point spline, we're really not seeing anything else. So let's go ahead and just add in a few more things. And there you go. Look at that. We are getting stuff rendering along our spline, not slime. And it's rendering things accordingly. As you can see, we can then just readjust those points, kind of move them around as we see fit. And all of a sudden, it's trying to render that one cube, as much as it can over our spline definition. And this is where, your tangents, for example, whoa, let's not do that. This is where your tangents give you the flexibility of adjusting those spline curvatures, and you can see how it kind of morphs and shapes our objects as we play with them. So this is kind of cool, but the boxes don't really do us much good. So let me just clean this guy up, and let's try with a slightly better shape. So if we look for our, I believe there was a cylinder here somewhere. Should go cylinder. Now, if you notice, our cylinder could make for a great pipe, but we have a slight problem. As you can see, while we're getting stuff rendering along the spline, it's not rendering it in sort of the orientation that we're expecting. In fact, it's kind of doing it the wrong way. We would expect the pipes to stack side by side. Never fear, we can quickly correct this, as the spline component comes with a forward axis. So let's go ahead and now add in a new property. So it's going to be the same sort of decoration for this particular property, and it's going to be an enum. So we're going to use enum as byte, because that is how you need to decorate your enums if you're going to expose them to a blueprint. So just a little FYI there for you guys. And we're going to use the spline mesh axis. And this is going to be type. Now, as you can see, this actually comes from a different inclusion, and my IntelliSense is unable to recognize it. But if we just go ahead and readjust our header inclusion, so if we take our spline mesh component from our CPP file, which is where that enum lives, and we drop it into a header, all of a sudden this guy stops complaining. So this is going to be our forward axis. And depending on this value being set, we're going to inject it into our spline component. So spline mesh component, set forward axis, and we're going to pass in our forward axis. So let me recompile and see what this looks like in our blueprint. All right, I'll recompile. Let's take a look at our blueprint. So there's our new forward axis, and if we flip this guy around, look at that. All of a sudden, we modify the whole orientation of all of those cylinders. And if we do it along the z-axis, as you can see, we get a fairly uniform pipe system. And now if you were to, readjust their position, maybe move this guy around, extend this guy out, kind of reshuffle this, all of a sudden you're starting to get slightly better shapes, and the orientation of the static meshes along the spline is doing kind of what you're hoping to do. Cool. But we can go a step further. So let's go ahead and look at, well, what if we want to have different objects rendering along the spline? Well, we're dealing with a single static mesh. What if we want to have alternating ones? What if we want to have alternating materials? So to do that, let me just go ahead and clean this guy up real quick. Let's get rid of all of these things. Cool. Let's go back to our C++ code. So let's go ahead and play around with the materials first. So why don't we set up two materials? We're going to have a one material for basically every other spline component and a default material for everything else. So let's go ahead and add a new property. It's going to be an edit defaults only. Yeah, I guess let's make it, let's make it all the things. Let's get two of these guys going, and this is going to be our material interface. And the reason I'm using the material interface as the data type is that encompasses the material instances as well as sort of the parent materials. So we're going to do this. And let's go ahead and add another one. So this is going to be our alternative material. Now in our spline actor, what we're going to do is, depending on the availability of said materials, we're going to do a little bit of checking as to where we are in our spline, and we're going to try to alternate their display. So we're already iterating over a spline count, which is cool. Now somewhere here at the bottom, why don't we do if default material and spline count greater than 0. So this is going to be our the next one in line. We're going to do a little modulus operation, which lets us know whether the current count is divisible by itself, kind of getting the odd even numbered chunks of our iteration. So if our material is available, and actually, let's make this our alternative material. So we're going to say, what are we going to say? We're going to say spline mesh component should be a set material, I believe. There it is. So we're going to set the index of 0 and our new material. Now, alternatively, if we have our default material, then we want to set that one. Otherwise, it will just default to whatever the material that is on the mesh. Let's go ahead and recompile and see what this looks like. Okay, so we're all recompiled. Let's see what this looks like in our editor. So if we look at our default material and our alternative material, now I'm just going to go ahead and pick some random materials here, and now if we go ahead and start drawing our cylinders, you'll notice that every other one, except for the beginning one, is starting to render the alternate material. Now, why is our default material not rendering? I think we might have a slight logic error there, but we're going to correct that in just a second. As you can see, we can now have alternate materials, and we can inject multiple shapes and whatever we want. Now, the other thing that's really quite handy with a spline component is also the beginning and the ending caps. So if you're building a fence, you could have sort of, actually, let's go ahead and do that. Let's make this a wall. Let's flip our orientation to be X. And what we want to do is we want to have starting and ending caps with our spline. So again, going back to our code, this ends up being just a little bit more logic that we need to apply as we're iterating over these spline points. So let's go ahead and implement that and correct this little this little issue that I was running into. So first, let's go ahead and add in 2 new meshes. Static mesh, and this is going to be start mesh. We are going to add an end mesh. And then within our logic here, what we're going to do is we're going to say if start mesh and actually let's do start mesh and spline count equals 0. So our very first one, we are going to say actually let's steal this line from here. And we're going to replace this with our start mesh. We are now going to say spline count. Actually, you know what? Let's do this. So this is going to be our ending point. So I guess all we really need for the ending cap is, where is Spline Component? Get number of spline points greater than 2. So I guess we don't want an end cap if, oops. If our spline, fence wall thing is too short. So what we're going to do is our spline count is less than spline component, get number of spline points, minus 2. So this will be our end cap. And start, and alternatively, let's do on else. Okay, so, and this is going to be our mesh, and this is going to be our end mesh. And again, let's make sure that this guy is not null before we leverage him. End mesh, end mesh. So let's recompile and see what this looks like. Okay, so going back to our editor, as you can see, our our spline got updated with the with our default and our bush-based materials, and then we have our start and end mesh. So why don't we do let's do a cube, and for the end, let's do a not cube. Let's do a pillar. No, not a pillar. Something different. Shape cone. Sure. Okay. So while this example is a little janky, as you can see, we can have starting caps, a bunch of stuff in the middle, alternating materials for all of those components, and we can even say to ignore the starting caps and the end caps from the material changes. So let's go ahead and add that in real quick. And only do the material alteration while we're processing the middle chunk of our spline. Let me just recompile real quick. Okay, let's see what this guy looks like. So just recompile, and there we go. So our middle bits are having the alternating materials applied. Chair, I don't know. Let's pick clay new. Let's give it a second to recompile the shaders, and it should just manage everything accordingly. chair. Let's do pebble. But anyway, you get the idea with the alternating materials. Now, as you can see, we are also adjusting the forward axis for all of the models within our spline. We can individually control these values, and we can also kind of reorganize this structure a little bit. So let me just go ahead and spend a few minutes adjusting this, and I'll walk you through some of my changes. Okay, so what did I do in the last few minutes? I've gone ahead and created a new enum that's going to allow us to determine which type of mesh we're going to be processing along our spline. So these are the three that we went over, the sort of the default ones, start and end. And I've also gone ahead and created a struct. And I don't want to spend all the time going over what a struct is and how it works, because you guys can reference the previous tutorials for that. But what this guy is going to entail is our mesh, our forward axis, our default, and our alternative material. And I'm just defaulting our forward axis to the X orientation. So now that we have this enum in the struct, I've gone ahead and included a new property on our spline actor, which is a map of these spline mesh details of our structs attached to this enum. And now we're going to go ahead and just modify our the internals of our onConstruction method to reference set changes. So as you can see, this guy no longer is applicable because I removed our mesh property. So we're going to just adjust this component a little bit, and we're going to say if our spline mesh map num greater than 0, then we want to continue. So we're going to do this and take these guys and just nest them. And now we need to process our individual meshes. So let's go ahead and actually define a couple of these local properties that we're just going to fill in with our appropriate values. So fspline mesh details start mesh details equals null pointer. Always make sure to initialize your variables, otherwise the editor will complain. And then we're going to say, hey, does our map contain a starting mesh? If it does, let's go ahead and grab it. Mesh map, find, and spline mesh start. So that gets our start mesh. I'm just going to copy and paste this. This is going to be for our end mesh. And you know what? We're going to do the default one right up here. So we're going to say default, and let's just say default mesh details. And no, I don't want you to correct everything. Default mesh details. There we go. Okay, so that gets our 3, but let's just quickly exit out of this if we don't have a default. No default, no. And that is simply to avoid further processing if we don't have any of this stuff set up. Okay, cool. So we have our 3 values now. What we need to do is actually go ahead and move the forward axis setting to be within our individual definitions here. So actually, before we do that, why don't we do this? If start mesh details and start dash details mesh, and we can do that. And spline mesh component, set forward axis to be the start mesh details forward axis. So we no longer need this guy. That goes away. Now let's do the same thing for our end mesh details, and we also want to make sure that the mesh of that struct is available. So we have that, and we're just going to take this value and put in our static mesh, and same thing for our forward axis. And again, if we want to be just a little bit better programmers, we would move this into a local variable, and then we only call these setters once rather than the way I'm doing it within the individual ifs. But, you know, this is further refinement and optimization that can always happen at the end of your development cycle. Don't prematurely optimize, get the thing working and operational before you dive into those additional details. And let's do a quick else, but let's also ensure that if, well, actually, we would not be here if we did not have a default mesh. So default mesh details, mesh. But you know what? Our check is actually bad because the mesh could be missing. So let's do this. If, as you can see, I'm being cautious about a lot of this null safety because I have had my editor crash just far too many times. Okay, so there is our default mesh. And let's go ahead. Oops, sorry. Let's do the forward axis. What am I doing? Here's our forward axis. And now we can say, get the alternate material, if it exists, and get the default material. Again, if it exists. So let me recompile and see what this looks like. So let's take a look at our blueprint now and see what our map looks like. As you can see, our blueprint got blown away, no more meshes. We have a singular map now. One thing to note with a map, you cannot add multiple values with the same key. So if you're expecting to add, default mesh, a starting mesh, and an ending mesh, this guy here will default to the default mesh as the first value, which means when you try to add a new element, nothing will go through. So, change that to be an ending mesh, add it in, starting mesh, add it in, and then there's your default mesh. So you just have to ensure that if you are using a map that you have individual key value pairs. Alternatively, you could have 3 separate sets of properties instead of using a map. The map is handy as it gives you the flexibility of growing your enums. If you want, for example, alternating meshes between and the middle or some other sort of combination of. But in our case, we're just going to use this. Again, our properties were copied and pasted from our initial definition. So let's do our ending mesh. Let's do a cube. Here's our cube. Let's do our starting mesh. So this will be maybe a sphere. And then our middle mesh, let's do a pillar. Pillar. Pillar frame. Now, Now, what's cool about this setup is because we've explicitly separated each sort of mesh definition, I can now go ahead and change the... Sure, I want to pick the cube, which rotates in all the same orientations. But as you can see, I can modify the orientation of each component now independently of each other. Likewise, I can assign the materials as I see fit, and if I put in logic for these guys here, the same thing would happen. So let's go ahead and drop this guy now into our level and see what happens. And we got a crash. So after messing around far too long with this problem, it simply turned out that the blueprint that I was working on, for whatever reason, was stuck within the editor cache or memory space, and it just wasn't working until I basically deleted and recreated this spline test blueprint. So not quite sure why that happened, but in the meantime, I also went ahead and modified our code slightly while I was troubleshooting this to include some spline points, just because I was trying to kind of compartmentalize my code. But looking at this, now if we go ahead and drop this blueprint into our level, and you can see I modified a couple of the shapes we were using just to have a sort of an obvious starting and ending point. Actually, let's go ahead and add in just different materials, so we're back to where we left off. Alternative material, let's do new. Sure, let's do old for this one. Okay, cool. So as you can see, there's our blueprint being reflected in the level, and now you can simply go ahead and add in as many more nodes as you see fit. Go ahead and start creating some sort of little walled off area if we so choose. Obviously these shapes are garbage for this type of prototyping, but I think you can get the point. And if we run our game, let's get out of our arm stance. As you can see, these just become regular actors within the world. We can interact with them, we can walk. Collisions would be detectable if we were dealing with them. But yeah, there you go. And very quickly, if we so chose, we could go ahead and just modify this to be our cylinder. We can flip the rotation on this, so it's Z. We can go ahead and modify the starting meshes. So let's go ahead and make these guys I don't know, let's do a cube. And let's do this guy to be another cube. Very quick, very simple. Everything ends up being reflected in our levels, as soon as we just modify a couple of our properties on our blueprint. We can edit time, go ahead and, tweak these values and reshape our spline as much as we see fit, whatever suits our sort of artistic needs. All this is nicely reflected within the level. I gotta change our combination so it properly doesn't kick when you get into the level, but yeah, there you go. Splines, alternating materials, alternating meshes, go ahead and play with it. Over the next couple of tutorials, we're also going to be looking at moving things along a spline, including our AI, as well as some prompts within our level. I hope you enjoyed this tutorial, and I hope to see you guys next time.